So let's take a look. The distance, so they want us to find the displacement, and they want us to find the distance traveled by the particle during the given time interval between 0 and 3. So let's start with 69. In 69, we have v of t equals 3t minus 5, and the time interval between 3 seconds, 0 and 3 seconds. First, they want the displacement. The displacement is basically the integral from 0 to 3 from v of t dt. Whatever it is. It could be positive or it could be negative. So if the initial point is here and the end point is here, the displacement can be negative. But the total distance will never be negative because it's an absolute value. It's this distance plus this distance plus this distance. But the displacement could be positive if the end point is on the right, and if it could be negative if the end point is on the left of the initial one. So let's see what we get. So the displacement the integral from 0 to 3 from 3t minus 5 dt. Again, there is no need for substitution here because it's direct. So this is 3t squared over 2 minus 5t from 0 to 3. When we plug in 3, we get 9, so that's 27 over 2 minus, when we plug in 3 here, minus 15. There is no need to plug in 0 because I'll get 0 in both cases. So look what happens here. So this is 27 minus 30. So this is negative 3/2. And this is in meters. Let's check the measurement unit to make sure. Yes. So the displacement is negative. Now they're asking us to find the total distance traveled by the particle. Okay, fine. So for the total distance, we still have the integral from 0 to 3, but this time of the absolute value of 3t minus 5 dt. If you remember the absolute value of 3t minus 5 has two possibilities. Can anyone give us those two possibilities? What are they?
When t is negative and t is positive?
No. Careful. So what are the two options?
Yes, it's the whole value?
Of course. Of course. That's a definition. The expression in absolute value equals the expression if the expression is greater than or equal to 0. The expression is, second option, negative the expression when the expression is less than 0. Absolutely. Is that clear?
Yes. Thank you.
Okay. So then 3x minus 5, 3x minus 5, 3x minus 5, and 3x minus 5. So then the absolute value of 3x minus 5 is 3x minus 5 if x is greater than or equal to 5/3. And it's negative 3x plus 5 if x is less than 5/3. Is this okay?
Yes, thank you.
Perfect. So now, how do we split this? Keeping this in mind, how do I determine the integral from 0 to 3 from that absolute value?
0 to 5/3 and 5/3.
Yes, exactly. Which one goes in here?
Negative 3x plus 5.
Yes, because it's less than 5/3 right here. Negative 3x plus 5. And of course, the other one from 3x minus 5. Perfect. So now let's do this. We continue. So negative 3x squared over 2 plus 5x from 0 to 5/3 plus 3x squared over 2 minus 5x from 5/3 to 3. We plug in 5/3. Negative 3/2 times 25 over 9 plus 25 over 3. Luckily, I don't have to plug in 0 because I get 0. Plus, I plug in 3. 27 over 2 minus 15. But minus, be very careful with the minus. Use parentheses so you don't miss anything. So this is 3/2 times 25 over 9 minus 25 over 3. Of course, these are not friendly calculations, but we have to finish them up. Good. So I'll simplify by 3. Negative 25 over 6 plus 25 over 3 plus 27 over 2 minus 15 minus 25 over 6, but plus 25 over 3. Okay. This with this is negative 50 over 6. This with this is positive 50 over 3. And I still have a 27/2 minus 15. So the least common denominator is 6. Okay, so this one needs a 2, this one needs a 3, and this one needs a 6. Careful with my numbers. Make sure I don't mess up here. Plus, and I think that this is 81. And minus, how much is this? 230 times 3, 90. Yes. Okay, so what do we have here? The answer has to be positive. And we can check with the calculator just to make sure. So, because I don't know if I don't think I made any errors, but who knows. So this is positive 10. So this is 91 minus 50. So I got 39 over 6, or 13 over 2. Let me do this one more time. So this is 10, 91. Oh, yeah. So that's wrong. So 91 minus, I meant to write 41. So 41 divided by 6. I don't know why I changed my mind halfway. So 91 minus 50 is 41 divided by 6, and that's it. So just this time I would like to check just to make sure that I don't have a calculation error. Where is it, my calculator? Okay. So careful how you enter something like this. So we have oh, never mind then. So 9. Good. So from 0 to 5/3. And the first one is negative 3x plus 5. And dx, of course. And then the other one plus another one from 5/3 through 3. And 3x minus 5. And dx, of course. So now when I hit enter, I should get this 41 over 6, and I'll check what 41 over 6 is. So 41 divided by 6. And if I don't get the same gibberish, then I know something is whoops, and I have to go back. But I get the same thing. So that was correct. So that was the total distance. So the difference between displacement and the total distance is the total distance can never be negative, but the displacement could be negative depending on where the particle is landing. So in our example, we did get a negative displacement. In other words, the particle starts here, but somehow ends up to the left of that point, of the initial point. But the total distance, and of course the measurement unit, meters, whatever that is. Very good. Let's take a look. So same type of question for the total distance. Find the velocity at time t, and find the distance traveled during the given time interval. Now let me know if we need another example like this. If we do, let's choose. If not, I'd like to practice. I'd like to show you. Yeah, let me show you this because I don't want to forget. Something very important, especially for those who move on to Calc 2. For those of you who don't need Calc 2, maybe this is not as important. But when we integrate cosine, then we know that we get sine x plus a constant c. But my question is now, what if I have cosine 3x dx? Yes, I will use a substitution, u equals 3x and du equals 3 dx. But it's very easy to see what's happening here. It's basically sine 3x divided by 3 plus a constant c. Why? Because when I differentiate this, I get cosine times the inner function with prime, which is 3, and that will take care of it. But yes, you can go through the steps. The same thing with a function like e. Can anyone tell us what is the integral from e to 5x dx equal to? It's okay if you're wrong, no problem.
5e to the 5x.
So, but over. It's over, like here. Because when you differentiate this, you get e to 5x prime, e to 5x times 5. You simplify and you get that. Is that clear?
Yes, thank you.
Perfect. What about the integral from e to 3x dx? Well, let's make it a little bit more interesting. Minus negative 3x dx. And again, I'm not saying that you should not use a substitution. You can. But this is, I think, straightforward, and it should not require a substitution.
Would it be flipped?
So what would you write?
Could it be like 3 divided by e to?
But it's going to be the same thing. It's going to be e to negative 3x divided by negative 3 plus a constant c. So the fact that we changed the, so let's check. So when we differentiate this side, we get e to negative 3x times the inner function prime divided by negative 3. These two go away, and we get that back. Is that okay?
Yes.
Perfect. So I wanted you to remember this because it's a shortcut and it's worth it. Okay, so now let's take a look at another. Do we want to go to more integration, definite and indefinite? These are from a different section.
Yeah, can we do 51?
Yes. 51. Perfect. So 51, the integral from 0 to 1 over the square root of 3 from t squared minus 1 over t to the fourth minus 1 dt. Again, this is a situation in which this is typical for partial fraction decomposition. So now let's see what can we do here. So let's see if I simplify this function, if I can. So, oh, I don't need to do that. I don't need to factor. I did, but that's okay. So the denominator is t squared plus 1, and t plus 1, and t minus 1. So these two will go away. Okay, so this is a very straightforward situation. So let me start from the beginning and show you what I just did. So t squared minus 1, if you don't factor the numerator, but you have to factor the denominator, t squared plus 1 and t squared minus 1. And then you simplify these two. So the function becomes t squared plus 1. So this is the integral from 0 to 1 over the square root of 3, 1 over t squared plus 1 dt. And we know the final answer for this. Which function prime, because this is from 5.4, so we didn't have any substitution in 5.4. 5.5 has substitution, so there is no need to even think of substitution for these problems. But we should always think. So what function prime is 1 over t squared plus 1?
Arctangent?
Yes. So I have to plug in 1 over the square root of 3. The square root of 3 over 3, actually, minus arctangent 0, which is 0. And we just had this situation a few minutes ago. So remember, for arctangent, it's either 1/2 over the square root of 3 over 2, which is for pi over 6, or the other way around. So this is the pi over 6. And you can always check, of course. How would you check? You will put in the graphing calculator, as we just did, and then you will have to approximate this to see what it is and make sure that that's correct if you want to check.
Could you show us how to put in the calculator again?
Yeah.
Or is there?
Yeah, you go to 9, math and 9. Not all calculators have this. In this case, from 0 to 1 over the square root of 3. And you can put in the simplified form or not, it doesn't matter, but be very careful how you put it in. T squared minus 1 divided by t to the fourth, in parentheses, t to the fourth minus 1. Without simplifying the fraction, we can't proceed. And when I click enter, I have to get pi over 6, but it's going to be a gibberish, right? So pi divided by 6, and all digits have to be identical. If they're not identical, something is terribly wrong. And then I have to go back to the drawing board. Is this okay?
Yes, that's fine.
Perfect. Fourteen, 13, 12, 11, 10, 9, 8, 7. I want to go back. As you know, I will not be able to sleep tight. I I need to go back to that number 80. So x to 1/2, 1 plus x to 3/4, and dx. So the notation, so we had, yes, u equals 1 plus x to 3/4. Yes, x to 3/4 equals u minus 1. Yes. Du equals 3/4 x to negative 1/4 dx. Okay. Yes, that's correct. So du 4/3 du equals x to negative 1/4 dx. Okay. We changed the limits of integration, correct? Yes, we had, what did we have? 2 to 9, right? Yes. 2, yeah. Yes, 2 to 9. Mm-hmm. X to 1/2, x to 3/4, and x to negative 1/4. Yes, that's correct. That's x to 1/2. Oh, I see. Oh, I see. Okay. So that's why I did not need that cube root. Okay, I see now. So 4/3 du. We replace x to 1/2 by x to 3/4 times x to negative 1/4. So that was the trick. I see now. That's why. And then this was u. Then x to 3/4. And yes, okay. So this is our 4/3 du. And x to 3/4 is u minus 1. X to 3/4 is u minus 1. So that was the trick. To notice that x to 1/2 equals x to 3/4 times x to negative 1/4. That was the algebraic trick. So then we have the integral from 2 to 9 with 4/3 in front, from 1 minus 1 over u du. So this is 4/3 u minus natural log of the absolute value of u from 2 to 9. So 4/3, when I plug in 9 minus natural log 9, minus 2 but plus natural log 2. Or 4/3, 7 minus natural log 9 plus natural log 2. I see what happened. So this is what I had, but I did not split. The reason why, so I had everything like that, but the cube root is not necessary because all we have to do is just write the cube root of x, the fourth root of, I keep saying the cube root, I'm not sure why. So the fourth root of x to the third, the square root of x can be written like this, because 3/4 minus 1/4 is 1/2. So that takes care of the cube root. But I still would like to check. Let me share my screen. And I had, so what was it? 1 to 16. From the square root of x and divided by, don't forget parentheses for the denominator, 1 plus x to 3/4. Close the parenthesis for the denominator and go outside to dx. And the answer should be some gibberish. And now I'm going to check the 4/3. 7 minus natural log 9 and plus natural log 2. And close the parentheses. So when I click enter, I have to get this, whatever this is. If there is anything missing, then it's incorrect. Okay, good. At least we solved that. Thank you for your patience.